So from your textbook, I'm taking a look at example 1.3.1. It says, suppose we have this candy bar Yummies, and Yummies had 40% of all sales of the top 3 candy bar purchases during the previous year. Notice all sales. There's that word all. We're talking about the whole population. So this number 40% is a population parameter. It is the population proportion pie. They are telling us that if you look at all of these candy bar sales, 40% of them are Yummies. Then, during the previous year, a sample of 104 of these candy bar purchases were examined. So that's a sample size of 104, n equals 104, to determine if in our sample what percentage of them was Yummies or not Yummies. It says we have a simulated distribution of sample statistics. There it is. It looks like that normal curve. It looks like it's going to be centered, as we expect, at pi equals 0.4, the population parameter. And this was generated with a computer applet. It shows simulated statistics that we'd find if it were true that 40% were purchased in the population. This distribution of sample statistics shows statistics where the sample size was 104. You will also notice that the computer actually tells us the mean and the standard deviation of this distribution. So the mean is 0.4, like we expected, and the standard deviation is 0.049, so it's approximately 0.05. Now, I have a series of questions that follow that are asking me to use the empirical rule, the 2 standard deviation rule, etc. Before I even look at those problems, I am going to go through and I'm going to add in these vertical lines that represent those standard deviation chunks. I am going to line it up with these rules up here, which relate to how many standard deviations away from the mean we are. Okay, so I'm going to do that first, and then I'll be able to easily answer all these questions because they all are going to go back to those values. Here is what I came up with. I have 0.4 in the center, the mean. Then if you add 0.4 plus the standard deviation, 0.049, we get this first vertical line to the right. And then if we take that, 0.449, and we add the standard deviation, 0.049, we get this third. Going backwards, we take 0.4 minus 0.049, and we get 0.351. And repeat, we take the 0.351 minus 0.049, and we get the 0.302. What are these again? We're saying how many standard deviations away from the middle. So the center line is, I'm going to call it 0. It's 0 standard deviations away from the mean. The first vertical line is plus 1. It's 1 above the mean. 1 standard deviation above the mean. The second vertical line is 2. This one is 1 below. This one is 2 below. So this is how many standard deviations above or below the mean. Next, I might just note to myself, the empirical rule tells us that the percentage of sample statistics that will fall between 1 standard deviation below and 1 standard deviation above the mean is 68%. So we're going to find 68% of the data between 0.351 and 0.449. If we go from 2 standard deviations below up to 2 standard deviations above the mean, 95% of the sample statistics will fall in that range. Okay, so I've kind of labeled everything here. I now should be able to pretty quickly answer the questions posed to us. Okay, so it says here to use the empirical rule to complete this sentence. Blank percent of samples had statistics where more than 49.8% of the 104 people purchased Yummies. So notice this percentage is talking about a sample statistic. They're saying what percentage of these statistics are higher than 49.8%. These values along the horizontal axis are sample statistic values. They are the proportion of the sample that purchased Yummies. in the distribution label, they are labeled as decimals. They're labeled as proportions. But recall that you can certainly think of them as percentages of the sample. This is 30.2% of the sample. This one is 35.1% of the sample. This is 40% of the sample purchased yummies. This is 44.9% of the sample purchased yummies, and this one is 49.8% of the sample purchasing yummies. They're asking us what percentage of these were more than 49.8%, which is that one right there. We're asking what percentage of these statistics is up here, is higher than 49.8%. So to figure that out, let's look at the percentages from the empirical rule. From the empirical rule, it says 95% of the data falls within 2 standard deviations of the mean. That means 5% of the data is outside of 2 standard deviations. There'd be 2.5% of the data down here and 2.5% of the data up here. So 5% total outside of that range. So what percent of the samples were more than 49.8%? 2.5% of the samples had statistics more than 49.8% purchasing yummies. Part B, use the 2 standard deviation rule to complete the sentence. It would be unusual to have a sample of 104 purchases where more than blank purchases were yummies. The word unusual means outside of 2 standard deviations. So unusual samples are those up here in the unusually high realm and down here in the unusually low realm. And down here in the unusually low realm. They're asking, it would be unusual to have a sample where more than blank percent of purchases were yummies. That would be more than 49.8%, right? This is that cutoff for unusually high sample statistics. Part C says it would be unusual to have a sample of 104 purchases where less than blank percent of the purchases were yummies. So the cutoff for unusually low is this 30.2% value. So if you get a statistic, a sample where 30.2% or lower is purchasing yummies, that would be unusually low. And lastly, Part D says to use this 2 standard deviation rule to complete the sentence. When collecting a sample of 104 purchases, the usual expected statistics are those that have between 30.2% and 49.8% of the purchases being yummies. So those are like your cutoffs for unusual statistics versus unusual statistics. You locate where the 2 standard deviation marks are, and statistics beyond those are unusual. Statistics between those are usual and expected.